Hey guys, Chili here. Welcome back to Intermediate C++ Tutorial 14. In the last few videos, we've been focusing on, specific things like surface, font, animated characters, but we haven't been learning any new C++ features, and I feel the hankering. We need some new C++.
Just hook it to my veins!
So today we're going to learn how to make our own templates. And I've already gone over the basics of what templates are in the video on std vector. That's Intermediate 8. So if you find yourself lost in this video and you skipped video 8, go back and watch that fucker. Now, whenever I find myself confronted with a new language feature, first question I ask myself is, why does Chili care? Why do I need this? What does it do for me? Now, with templates, well, let me show you why you care. We got Vec2, right? That's great. It's very useful, obviously. And Vec2, also very useful. Now, Vec2 was created basically by copy and pasting Vec2. We copied this shit, we pasted it in here, and we changed all the floats into ints. And that works. It's kind of inelegant, right? Now imagine we also wanted a vector of doubles or a vector of unsigned shorts. We would have to copy and paste for every one of those, and it's very bad to have all that copy and pasted code for a number of reasons. What we want to do is we want to get the compiler to do that shit for us, and we can with templates. So let's templateize the Vec2 class. So what you do to make something a template class is you type template, funny enough, and then angle brackets. When you think templates, you think angle brackets, std vector. Now, the thing that goes inside the angle brackets is going to be the template parameter. That is the thing that you are parameterizing this template class on. Template class is it's a kind of like a cookie cutter for classes. You use it to create different classes, and you create them with some variation. The template parameter tells you what that variation is going to be. So we are going to vary the type name. So we type type name and we just type a capital T. It's very common to have template parameters as capital T. Now I like to put my template shit on a line above the actual class thing here. That's just my style. So now we have a Vec2 class templated on a type name T. So what we can do now is, instead of having float X, float Y, we now have TX and TY. Now, we've also got to replace, the floats and stuff in here with T, but there is one important thing that you must remember when you're dealing with templates, and that is, when you're dealing with template classes, you have to put all of the code inside the header file. You cannot put the implementation of the functions in a separate CPP file. This is not allowed. I repeat, you have to put it all in the header file. So we're going to cut this out here. So we've pasted those function definitions right in here. Now we don't need these Vec2 double colons. They don't hurt, but we don't need them. And I want to get rid of these spaces too. So let me just clean that up. We'll get rid of the colon cancer like this. And now we can replace all the instances of float with just T. And there you go. So now all the things that we're taking a float will take T. So if this is templated on an int, then these will take int. If it's templated on double, these will take double, etc. Now Vec2 includes CMath, so let's put CMath up into here. CMath, there you go. And that is about it. So now we don't need this guy anymore. Go to hell. And we don't need Vec2 anymore. Also go to hell. And we don't need Vec2.h anymore, because we now have one template class that is going to work for everything. Now Vec2 isn't a thing anymore, so we got to get rid of this, and that means that this operator here isn't going to make much sense. So let me we'll just delete it for now. All right, let's try to build the project like this. So obviously compiler is mad because it's a lot of source codes are trying to include Vec2.h, but that is not a thing anymore. So let's go throughout the entire solution and let us replace Vec2.h with Vec2.h. It's going to give us a nice little warning here. Do it. 3 occurrences replaced. Build. All right, way more errors now. Much better. So what have we got here? Holy shit, so many errors. Well, Obviously, these guys are going to be no good because vec2 no longer exists. We only have a vec2. Now, we've also got a bunch of errors in our character class with vec2. And you might say, well, vec2, that is a thing. It does exist. We did define it. Why is it mad? Well, it's mad because vec2 is now a template class. So you've got to tell it, I want a vec2 of float, for example. And then it would be happy. So we would have to go through all this goddamn code, replace vec2 with vec2 float, and replace v2 with vec2 int or whatever. But I got a better solution for you guys. It's going to involve a new keyword, and the keyword is typedef. And what typedef lets us do is lets us create an alias of an existing type name. So we type in an existing type name, and let's type in vec2 float. And we want to define that as vec2. But this is a problem because vec2 already exists, so it doesn't make sense. So let's go up here and let's rename our template as vec2 underscore. So vec2 underscore is going to be the template class name. So let's replace all vec2 with vec2 underscore like this. And then here, vec2 underscore float will be redefined as just vec2. And then vec2 underscore int will define that as v2. And now we don't have to change shit in any of our other files because these names are now valid. This one will just mean a vec2 templated on float, and this one means a vec2 templated on int. Now, if we build that, we see we get much fewer errors. We only got one here, and that is typecast cannot convert from vec2 to v2. So we don't have our conversion. We can make a conversion, and let's do that right now. So we'll go to vec2.h, and let's make a conversion. We'll do the different way of making conversion. We'll make a converting constructor. So vec2 underscore, so template vec, and we will allow conversion from constant vec2 underscore float. So this allows conversion from a vec2 float into whatever we are. So we'll initialize x with current templated type. So we'll cast source.x to whatever type of vec2 we are in our current object, and source.y, cast that, and there you go. So this should allow casting. Let's build it. And there you go, that works. We did it. Now we've replaced our vec2 and v2 with a templated vec2. Now there's still a minor problem here. No, well, there's actually two problems here. If I try to create with default constructor, it doesn't work. So I have to add default constructor in here. There, added it, and this should now be fine. So I'm creating a v2, and then I'm calling get normalized on that v2. So it is an int vector. And if I compile that, I'm going to get warnings. It'll build, but there will be warnings. Here you see succeeded. Now, what are the warnings? Well, argument conversion from float to int, possible loss of data. So here, when we call get normalized, we're doing constant t length is equal to get length. This is a problem because this was going to become an int, right? And now we're comparing an int to a float, and here we're going to divide a float by an int. So these aren't compatible. Making your constants in here always float will only work if you have a vector of floats. So what we do instead is we make them of type t. So just putting a conversion t in front of the type here will make it whatever we are currently templating the class on. And same thing here, get length returns type t, so we should probably put a t in front of here just to get rid of any annoying compiler warnings. And I just want to stress here that the way that templates work is they are very flexible. So a template type name parameter will accept any type that you throw at it, and it'll compile as long as that type supports the operations that are going to be applied to it. So this code here, vec2 of string, this compiles. This will compile fine, and we can run it. And you can see here, we've got S1 is a vector of strings, x is equal to pubes, y is equal to stash. We can execute this line, we can add two string vectors together, and the result of that is what you would expect. X is equal to red pubes, y is equal to porn stash. Now, if we try to do an operation that isn't supported by the type, then we're gonna have a problem. And you're going to get a bunch of weird ass errors in here, but if you look down at the bottom, you'll see error, binary, minus operator, std string does not define this operator. There's your root problem for all of these errors. And this is very common. If you have a problem with your templates, it's going to generate a whole shit ton of errors. And oftentimes you have to go down to the bottom to see what the root cause was. Templates don't care who you are, where you're from, what you did, as long as you support the required operations. So let's commit those changes to the repo. And now let's turn our attention to recti. Because recti, obviously, eventually we're going to want to rectf. And we're not going to want to copy and paste that shit. So let's templatealize recti while we're at it here. So again, I renamed to rect underscore, template, type name t. All that stuff is the same. Left, right, top, bottom become t. Now, a lot of these functions take vectors as their parameter. So if it is a rectangle, an int rectangle, we would want to take int vectors. And if it is a float rectangle, we'd want to take float vectors. So we use the template version of vec2, and we use t as the parameter here. So you can only use the matching vector type when you're creating a rectangle. We can say bye-bye fuckboy to our recti.cpp. We don't need that shit anymore. And that should just work. We got our type defs down here for recti and rectf. Let me just, oh wait. Probably want to rename this now just to rect. And that means that we're going to have to go recti.h, replace everything in the solution. Yes, 2 occurrences replaced. If we build, it should work. It does work. So we have templatealized recti, rectf, whatever you want, rectd, rectum, damn near killed him. Now allow me to draw your attention to these sprite drawing functions here. If you look at them, if you look at their actual function bodies, you'll see that they're basically the same. Let me just bring up a couple of them here. So look at this one. Look at this one. They're basically the same except for the code inside of the for loops here. That's the only part that changes between all these functions. We're just copy and pasting and changing a little part of the code. Wouldn't it be nice if we could template our functions in the same way that we template our classes? Well, guess what? We can. All right, now before we jump into applying template functions to our sprite drawing problem, let's take a look at a very simple application, a simple example here. So template functions can be applied to member functions or just to regular free functions. So here we've got a situation where we've got a vector of ints. We're printing out that vector. So we've got a function that takes a reference to the vector, and it takes a reference to an output stream, and it just fires every element of that vector out into the stream. If we run it, should be able to predict what we get here. We just get all the numbers printed out in a line like that. Now say that we have a vector of floats and we want to print that motherfucker out as well. We've got a nice function to print out the elements of a vector. So let's use our function. So we call print vector with our float vector here and with cout. And the compiler says, no, fuck your shit. This ain't good. And why isn't it good? Well, if we look at a function, it takes a reference to a vector of ints. And this is a vector of floats. And you might say, well, they're both vectors and ints kind of convert to floats and vice versa. So why doesn't this work? And the reason why it doesn't work is, again, I've mentioned this before, but when you template a class, a template class, and you instantiate a new class, different classes from the same template are completely separate. The compiler treats them as completely different entities. So they don't convert to each other. They're not friends. They don't trade recipes or take turns babysitting each other's kids, is what I'm trying to say here. So if you wanted to print out this vector of floats, you'd have to make a new function that takes a vector of floats. Or you could template that motherfucker. So template type name t. So we're going to template on the type name that is the template parameter of the vector. So template like this. So it's going to take, it will only accept vectors, but it'll accept vectors of any type. Now in here, well, we're going to have a problem here. We'll build this. So it builds, but there's a warning, and it's right here, right? We are iterating over and we are copying into an int here, but it could be a float. It is a float if we do this call here. So what we should do is, well, we could make this t, right? And that would mean that it would be the same type as whatever is in the vector. Or we could make it auto. And auto is actually really fucking sexy with templates because it's very flexible. It molds itself to whatever type it is being input. So auto and templates are a fucking match made in heaven. But if we do this, now we see it works. Printed out our ints, printed out our floats. If you don't believe me, that's working as a float. I can change this to 3.1. And there you go, 3.1. Beautiful. Now let's get back to the problem of drawing the damn sprites. Now how we're going to solve this problem is we're going to use a technique, a thing called a functor. And that's it's just a dumb name for a very simple idea. There's nothing special to it. So what we're going to do is let's just create a namespace here. And we're going to call this one sprite effect. So here's where we're going to put a bunch of effects. And the effect, the functor, it's going to be a class. And we're going to call this one, let's call this one chroma. So this will be our chroma effect. Now, we'll give it a private. We're going to need color in here, I guess. So we're going to give it a private color chroma, and that is the chroma value to compare. So it's going to need a constructor. That'll look something like this, and it is going to need a function that will process the effect. Now, we could make the function just as a normal function, but functors generally, what they do is they override the function operator. So how do we do that? Well, we'll go void operator. That's not how you spell that. And then the parentheses, and then we put the parameters in here. So this thing is going to take a color, and that is the color of the source pixel from the surface, from the sprite. It's going to take int, xdest, and ydest, and those are the destination coordinates for the pixel on the screen, where it's going to go. And then obviously we're going to need reference to the graphics object to actually do the writing. And we'll make this const because it's not going to change the object in any way. And here we're just going to process the operation of doing a chroma key pixel draw. So all we do is we test chroma, and if it is not equal to chroma, we draw that pixel. Let's include graphics in here. Graphics.h, and that should make this guy happy. And there you go. So there is a sprite effect. This is the chroma effect. And when we create an object of chroma, we can call operator on that object, and it will process the chroma effect for a single pixel on the screen. And we can do the same for the other sprite drawing effects that we have. So substitution, its constructor takes a chroma and a substitution color. Operator, they all have to take the same parameters. And this one is going to compare chroma and then draw the substitution color. For copy, this is just a basic copy without any effect. Doesn't even need a constructor because there's no parameters, and it just takes the source pixel and draws it on the screen at the proper space. And then you got your ghost effect here, and again it does what I told you in the homework solution video. So now we have all these beautiful functors. These are called functors, function objects. Well, they're classes actually, but we create function objects out of these classes. How do we use this to somehow templateize our sprite drawing functions? Well, there's one thing we know about templates is that we've got to put everything in the header file. So first let's delete all this bullshit. We don't need it anymore. So get rect mate. Now let's copy some code from graphics.cpp. Let's copy draw sprite non-chroma. So we'll copy this guy and we're going to paste him into here. So here we go. We've got our three functions here. We will rename some bullshit. Beautiful. Now this guy, some of these functions want to know about assert. So we're going to include cassert. There you go. That'll make some other dudes happy down here. So draw sprite, draw sprite, draw sprite. Now, we want to templatealize these guys. So how do we do it? Well, it's same for a function as it is for a class. Template, and we can go type, name, and let's call this one E. E for effect. So these functions are going to take, they're going to be templated on an effect. Now, we have to pass in the function object. So we put in here, the function object is going to be type E, and we'll just call it effect. And the same here, it is going to be E effect. So because it's templated, we can pass in effects of different class types. Finally down here, again, E effect. Now, draw sprite is going to, this one is going to be passing in the effect into the next guy down the line. You will be passing along that effect. And in here, the implementation, we actually have to use the effect. So how do we use it? Well, we just type effect, that is our functor, and then we call its operator. Now the operator is going to take a bunch of parameters. It's going to take the source pixel from the surface, and that's just s.getPixel sx sy. It's going to take the destination coordinates on the screen. Those are calculated like this. And finally, the effect functor needs a reference to the graphics object. And since we are the graphics object here, we just pass a reference to ourselves. And here you go. We call the effect, and we do that for every pixel that we're drawing, and the effect will process it and do whatever the effect is programmed to do. So now we have a single implementation of sprite drawing, but we have parameterized it on an effect functor.
I want to take me to funky town.
If we try to build this, the compiler is going to be real mad at us for a number of reasons, mostly because now these functions like draw sprite substitute, they don't exist anymore. And normal draw sprite, it doesn't take that same number of parameters now because we've added the effect functor parameter. So what are we going to do here? Well, I guess we can just go down the list and replace all these guys with whatever is necessary. So draw sprite here. We need an effect functor, so let's include sprite effect.h. What we want to do is at the beginning here, let's create effect functor, and we're going to go not std, sprite effect, and this one is going to be a substitution effect, and we'll just call it effect E. Now the chroma is going to be chroma, and the substitution is going to be color. So we create a substitution functor object, and then we pass that object into the draw sprite function, and it will use that effect to draw a sprite. This is obviously not valid anymore. And why are you still mad at me? Maybe we need to get rid of these guys. I don't know. I don't usually type the colon stuff inside of a class definition, so I'm not sure. Yeah, it says overloaded matches int recti. Yeah. All right. We don't pass in chroma anymore because obviously, yeah, there you go. All right. So there's one down, many more to go. So again, here we're drawing with the ghost effect. So let us replace that with the draw sprite. We'll pass in the functor object. We'll just create it directly inside here. Same thing for here. Create the substitution functor with the chroma color and the substitution color. And that's this guy done. I mean, obviously the compiler is not happy about all this garbage in graphics.cpp, so let us get rid of that trash. And the last one here is animation draw sprite. So it's the correct name, but the parameters are incorrect. And here you will see the bad part of template errors, because if you look at this error here, it says term does not evaluate to a function taking 4 arguments. It doesn't make a lot of sense here. But when you see it, you understand that template here can be anything. The template accepts any argument and says that is going to be E. So what we're passing in here is we're passing in a chroma, which is a color. And what it is saying is, well, effect is a color, but color, you can't call a function on color. It doesn't work. It says it in such a way that Probably a lot of you are going to get fucked over by these error messages until you learn how to deal with them in templates. This is the bad side of templates. The error messages sometimes are extremely cancerous. And you just got to learn how to speak the lingo. So here we see, wow, we're passing in chroma. That's not correct. We want a sprite effect, copy effect. And this should allow us to build. And if you run it, you see everything now is working exactly as it worked before. No changes, except that the code is a fuck of a lot sexier now, because look at this. Now instead of all those bullshit draw sprite variation functions, we only have the one implementation here. There can be only one. And now anytime you want to create a new variation, a new sprite effect, you just got to add a new sprite effect functor here, and there you go. You've got a new effect. You can send that to your sprite drawing function, and it will draw your sprite with your new effect. So beautiful. There you go. Sprite effect functor system implemented. Now this idea of functors and about templating a function on a functor, this shit is super important in the standard library. It's used all over the place. So it's a very important idea that I wanted to introduce to you. Also, you might be wondering, well, if the sprite here, draw sprite, this is a template function, why don't we see any angle brackets? And the answer is there are you can put angle brackets for these functions, and sometimes you have to, but so I could do this. I could tell it, call this template function with this template parameter, and then I pass in the object like this. This would compile, this would work fine. You see, no problems. But we don't have to do it, and that's one of the beauties of template functions. If we pass in E here, the compiler can see E is of type sprite effect substitution, and so it will put this in here for us automatically, so we don't have to type the angle brackets. This is called template deduction. And it's awesome shit. So most of the time we don't type those angle brackets for template functions. We just pass it the proper parameters, and it will pick the correct template stuff for us and stuff it in there. One last thing here, we created this converting constructor to convert from vec2 float to any other type of vec2. But now let's say we want to convert from vec2 int to any other type. We'd have to copy this, paste it out. That seems dumb. What can we do about that? You guys already know the goddamn answer. Template type name T. So now we can convert from a vec2 of type T to our, no wait. T is already the template parameter for the current vector type. So we want another one. So let's see. We'll call it type name S, just because it comes before T. It doesn't matter. So now we can convert from a vec2 of type S to a vec2 of type T with this template parameter here, and we just cast to T here, and it'll work. And let's also make this explicit so that we don't accidentally convert. The compiler will tell us if we're doing something unless we do it explicitly. And there we go. That is the basics of templates. The most basic and the most useful use case for general programming here. It cuts down on a lot of copy and paste and a lot of redundant code, and it just makes your code sexy as fuck. So, beware of those error messages, but use templates when it makes sense. And for example, for this vector stuff, for recti, for the draw sprite functions, definitely makes sense. And if I lost any of you guys on this, don't worry about it. Don't panic. Come on the Discord or on the forum and message me, and I will. I'll try to set you straight. I'll try to give you this straight dope on templates. You can find links to those again, www.planetchili.net. All the links are there. But that's it for today. Thanks for watching. I hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.